Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function 1 over 2 minus e to the power negative x. What we have to do is we have to first sketch the graph, and we have to label any relative extrema, inflection points, and asymptotes to the graph of this function. Now, to solve this problem, it will take quite a few steps. So, we will solve this entire problem in 2 videos. Now, notice that to label extremas and inflection point, we need to compute the derivatives of the function, the first and the second derivative. So, in this video, we will compute the derivatives first. Now, look at the function. We have to find the first derivative. So, let me rewrite this function a little bit. So, let me take this entire denominator in the numerator as 2 minus e to the negative x to the power negative 1 using the property of exponent. And then let's compute the first derivative using this new expression for the function. Notice that this is going to be a chain rule. So, something raised to the power negative 1, you use the power rule first. So, you have negative 1, 2 minus e to the negative x to the power negative 2. And then chain rule says you have to take the derivative of the inside function as well. And the derivative is 0 minus e to the negative x times negative 1. Simplify a little bit. We have negative of 2 minus e to the negative x to the negative 2. 0 goes away, the negative and the negative is positive. This is just e to the negative x. And then rewriting one more time, we get in the numerator we have the e to the negative x with a negative sign. And then this negative 2 exponent, you can bring it in the denominator as 2 minus e to the negative x square. So, this is our first derivative. Okay, let's compute the second derivative now. Now, for that, we will use the first derivative expression, and we take the derivative of that. Notice that this is a quotient, and therefore we will be using quotient rule. So, let's do that. You know, the denominator gets squared. So, we have 2 minus e to the negative x square and then square again. And then in the top, you keep this function as it is. So, 2 minus e to the negative x square. And take the derivative of the numerator. So, it's negative e to the negative x times negative 1 because of the derivative of negative x. Okay, then you have a negative sign here, and then you keep the numerator function fixed, negative e to the negative x, and take the derivative of this denominator. So, this is 2 times, power rule first, 2 times 2 minus e to the negative x to the power 1, and times derivative of the inside is 0 minus e to the negative x times negative 1 because of the derivative of negative x. Let's simplify this expression quickly because it will help later. Okay, so first expression we have positive here. So, e to the negative x has a positive sign multiplied with this entire thing square. Now, here you have a plus e to the negative x, and then you have a constant 2, and then one of the expression here, and this final one is also positive e to the negative x. And denominator, see the square and the square, using the property of exponent, you multiply and then you get to the power 4. One more step, let's see if we can simplify this further. in the numerator, let's find out the common factors from these two terms. So the common factor is e to the negative x and 2 minus e to the negative x. So what is left from the first term? We have another 2 minus e to the negative x. From the second term, we have plus this 2 and one of these e to the negative x, because we have taken out 1 as a common factor. Denominator remains same. See, we have the same factor in the numerator and denominator, so we can cancel out one of them. And in the denominator, then we have 2 minus e to the negative x cube, because we're canceling one of the 2 minus e to the negative x factor. We'll have e to the negative x. And here, if you simplify, you have 2 minus of e to the minus x plus 2 of e to the minus x. So you get 2 plus e to the negative x. So that's the simplified form of the second derivative. So we will end this video here, and in the next video, we'll solve the problem completely.